Hello everyone, this is KP the Map G once again, and I have for you this 2013 free response question 4. Yesterday we answered parts A and B, and today we want to answer parts C and D. I enjoyed this one. This one's really good. You have to study it though to really understand the gist of it. Okay, but anyway, that's how you have. That's just how you do anything in algebra, math, calculus. You just have to practice it. You have to practice it and get familiar with it, and it'll help you out. Now, let's see what C says. What open intervals contained in the open interval 0 to 8 is the graph of f, both concave down and increasing? Well, let's look at that. Let's put down in abbreviation. We know that the interval is from 0 to 8, all of this. And we want the graph to be, we want to look at those parts of F. Where is F? Where is F? Increasing and concave. Concave up or down? Let me see. Concave down. Now, keep in mind, put a little question mark on the end of that. Keep in mind, this is the graph of f prime. To decide what to do, now f is increasing when f is increasing when f is greater than 0. Well, we already have f prime, and I believe we know by now that anything above the x-axis is going to be increasing. So from 0 to 1, that's increasing. From 1 to 4, that's increasing. From 6 to 8, that's increasing. But we also have a second part of that, and that's when it's concave down. Concave down, F is concave down when f double prime is less than 0. That is negative, right? The slope of f prime, which is f double prime, is negative. The slope leans to the left then, doesn't it? Well, let's see. Increasing from 0 to 1 is f increasing? Yes. Is f double prime concave down from this interval 0 to 1? Well, let's look at the slope. Let's just pick some points here. There's a point there. We'll just make a slope right there and a slope right here. Which way is that slope, or are all those individual slopes leaning? Well, we'll just put one right here on the outside. Put it on the outside. Tangent to the line, tangent here. Alright, I should probably have it on the outside right here. Those slopes are leaning to the left, aren't they? So yeah, concave down from 0 to 1, increasing from 0 to 1. You have to answer both of them at the same time. So concave down and increasing. Okay, concave down, let's say increasing first, concave down, and at the same time concave down when x is between 0 and 1. Now, do they include that or not? Do they make that inclusive? No, they don't. Well, alright. Well, keep B at the endpoints because at the endpoint, and this is 0 here, so I can get it. Alright, concave, increasing and concave down. Well, from 1 to 4. Well, actually, let's just look at from 1 to 3. Here's the pinnacle here. From 1 to 3, look at those. Well, it is increasing. Increasing, yes. Concave down, no. Because that slants to the right. Those slopes slant to the right, so that's out from 1 to 3. Alright, let's look at from 3 to 4. Actually, yeah, from 3 to 4. Increasing. Yes, it's above the x-axis. Concave down. Slope left, 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 left. Yes, on the interval from 3 to 4. Now, let's not go to 3 to 5 because what's happening here? Alright, that's true on both of them. Look at from 4 to 5. From 4 to 5, decreasing. Forget it, go to the next one. 5 to 6, decreasing, still below the x-axis. So, keep going. 6 to 7, or 6 to 8 rather. Increasing, yes. Concave down, no. And you might want to give a reason. And I believe right here, f prime is greater than 0. Concave down when f double prime is less than 0. Alright, this is positive. Yeah, positive here. Alright, above the x-axis. Alright, these are the only two on the interval. Alright, on the interval. Alright, right there. F prime is decreasing and positive. Let's see. On these intervals. Okay. And I think that's what we got. Yeah. Alright, concave down. Alright, yeah. That's what we have. And that's what we have to do. I would put something like this down. They see that, they gotta know that you understand when F is increasing and at the same time concave down. Alright, there it is. Well, let's go to G now. I don't think we will need our table, our graph. Okay, but let's take a look at it. Sorry about the inconvenience of erasing, but this little small board Well, I have no choice really. I don't know if I need this or not. Let's look at the problem. It says, well, we're not going to need it from here on out. Let's go ahead and flip the board over. We're going to need room. Okay. Alright, here we go. Let's put D right up here, y'all. Okay. And I'm sporting my KP the Math G shirt. And I'm in shorts because, I don't know if you can tell if I'm in shorts or not, but I am getting ready. Well, it cuts off here. So, probably couldn't tell me. I'm getting ready to go to the gym. I would like to get some of this off of me and gain a lot of this and muscle in my legs. Alright, well, putting that aside, let's do D. Well, they talk about the function G. Alright, just bear with me as I write this down. Is defined. Alright, defined by G at x. G at x is equal to F. Alright, that's in parentheses. F at x. And they're cubing that. Alright, and then they say if F at 3 is equal, I don't want to say it's a negative 5 halves. I thought it was 5 halves, but it's negative 5 halves, but okay. Find the slope of the tangent line. Find F-I-N-D. Bear with me, I'm sorry. Find the slope of the tangent line. We don't even need the equation, just the slope of the tangent line. Alright. Of G at x equals 3. Well, alright. I imagine eventually we're going to have to use that, huh? You reckon so? I do too. Well, let's go ahead and deal with this. Remember now, if I want to find the slope of G is found by by G prime, right? We've got to take the derivative. Always remember, slope, the derivative. We got to find the derivative of this. Alright, well, let's do that. G prime, you know what this is an exercise of. You'll probably see it in just a minute. I'm not going to say what it is, but I'm going to let you decide if you... Okay? Well, let's see. How do we do this? Now, if you're talking about the chain rule, well, actually, as a combination of chain and power rule, and you are absolutely correct. Alright, so let's see. 3, here's your power rule. Remember, do not change anything. Right there, I'll put a 2 there. I forgot to do that when I was practicing this. I don't know why I forgot, but I did. Now, F prime at x. Now that's the derivative of G prime at x. Now we want G prime at 3. Well, let's do that. G prime at 3. 3 times F at 3 squared times F prime at 3. Well, let's figure it out. We see that F at 3 is negative 5 halves. Alright. Now let's see here. F prime at 3. I'm trying to think, do I need to go back to that table or not, or to the graph or not? Let's see. It looks like I may have to. Let's go over there and see. F prime at 3. I don't know where else to look for it. We know this is F prime. F prime at 3. This is F prime. So F prime at 3 appears to be 4. 3 comma 4. Alright. So I'm going to multiply by 4 here. And I believe that's it right there. Yep, that's it. 3 times 4 is 12. I did have to use this after all. And once again, you have to remember this is F prime. So F prime at 3 is 4. Looking for that Y value there. That's all you're looking for. Alright, so you had to use this after all. Well, now 3 times 4 is 12. And this is going to be a positive number because this is a negative squared. So negative 5 squared is 25. And 2 squared is 4. 12, 4 goes into 12 3 times. 3 times 25 is 75. You know, that was the number that I wore when I played for the Haynesville Golden Tornado many years ago. I'll say, well, back in the 70s, late 70s. I wore 75 with pride. And I wasn't the best player, but my coach pointed at me and one other player and told the starters, if you want to keep your starting positions, you better play because these two fellas want your position. You know, I had a grin all over my face. But anyway, I enjoyed those years, and I wouldn't take anything for them in the world. I enjoyed that. I'm enjoying my life now. So anyway, this is KP the Math G, getting ready to sign off here with that signature clap. Please, if you will, if you haven't subscribed, please subscribe. If you would like to make a comment, please do so. I like comments once in a while, as long as they're good. Okay. And also, that like button is really just puts a smile on my face. But if you don't do any of that, I just want you to get something out of this. This is really good stuff here. I really enjoy doing this. You know how to make your own day. Just start doing some calculus now. Anyway, putting all jokes aside, I enjoy doing this, and I'm doing it not for me, but for you, and it keeps my mind sharp too. All right, well, KP the Math G signing off. Have a great day. Yeah, that was a good one.